Hello and welcome to the Studify Plus. We are starting the network analysis. In network analysis, this lecture we will try to approach the transient in using one more tool, that is Laplace transform. So just wait for a minute. Stop the okay. Uh, Here we are having the information about the batches available for preparation, and let me give you that information. These are the batches available, Arjuna batches available and L-8 batches available. So you can join these batches, and these are the contact number. So on this contact number you can join all any of the batches for preparation, structured preparation. So let's start our idea of the day, and that is how to approach the transient circuit with the help of Laplace transform. So first we will identify the basic information about Laplace transform. Means we don't want the Laplace transform in the totality. मीन्स हमें लाप्लास ट्रांसफॉर्म विद आरओसी पढ़ने की बिल्कुल रिक्वायरमेंट नहीं है. हमें चाहिए डिफरेंशियल इक्वेशन का सॉल्यूशन, और डिफरेंशियल इक्वेशन का सॉल्यूशन कैन बी ऑब्टेन्ड बाय वन साइडेड लाप्लास ट्रांसफॉर्म आल्सो. तो हम आरओसी की बात नहीं करेंगे जो आप सिग्नल्स में पढ़ते हैं, हम बात करेंगे लाप्लास ट्रांसफॉर्म की, जो कि वन साइडेड लाप्लास ट्रांसफॉर्म है. एंड मैं आपके सामने कुछ बेसिक लाप्लास ट्रांसफॉर्म रखूंगा. We will discuss a few basic Laplace transform which is required in this analysis. So can I say here, first we will discuss, heading is transient using Laplace ट्रांसफॉर्म. कि लाप्लास ट्रांसफॉर्म कैसे आपको ट्रांजिएंट को सॉल्व करने में हेल्प कर सकता है. तो लाप्लास ट्रांसफॉर्म का फंडामेंटल डेफिनेशन ही यही है कि लाप्लास ट्रांसफॉर्म इज ए टूल विच कन्वर्ट्स योर डिफरेंशियल इक्वेशन इनटू एल्जेब्रिक इक्वेशन. तो अल्टीमेटली वी आर राइटिंग द सॉल्यूशन ऑफ डिफरेंशियल इक्वेशंस. तो डिफरेंशियल इक्वेशन को सॉल्व करने के लिए दो तरीके हैं. इधर यू कैन गो बाय डायरेक्ट द सॉल्यूशन ऑफ डिफरेंशियल इक्वेशन, और व्हाट इज द सेकंड मेथड, you bring that differential equation into Laplace domain and then convert it into inverse Laplace. आपको जो final answer देना है that you will give in the time domain. So always remember, we will convert our time information, can I say, transient using Laplace transform is the method in which first we will convert our signal. Let's say we are having one signal is Vt, It or Vt. These are your signals. You will use Laplace transform, and always remember what I am trying to convey. Here we are having the differential equation in which variable is what? With variable Vt or It. This differential equation is available to you. Now what you will do, you will take Laplace transform You will take Laplace transform so that you can convert this differential equation into algebraic equation. Here the equation available to us is algebraic equations with variable Laplace domain variable, which is Vs and Is. But you cannot answer in the Laplace domain. You will always answer in which domain? You will always answer in the time domain. So you have to take inverse Laplace again. You will take inverse Laplace again. Inverse Laplace again is required for the final answer of Vt or It. So there are two methods. Either you can solve your differential equation directly, or you should solve your differential equation with the help of Laplace transform. We have talked about the differential direct solution of the differential equation. Here we are solving the differential equation with the help of Laplace transform. So in this method, what is required? In this method, these two things are required. You should have the basic one-sided Laplace transform. You should have the little bit of information about basic one-sided Laplace transform. Most of our circuit will not go beyond two variables, so order 2. So we should be aware with the basic Laplace transform. One more thing, if you talk about the Laplace transform is, if I talk about the Laplace transform, I can say that Laplace transform is a variable which converts your differential equation into algebraic equation. Laplace transform is a tool. It's a tool to convert differential equation into algebraic equation. What is Laplace transform? Laplace transform is a tool which converts your differential equation into algebraic equation. Means, suppose you are having this differential equation dit divided by dt plus p times of it, and if you take Laplace transform of this equation, what this equation will be? This equation will be s into I of s plus s into I of s plus p times of I of s, and if you take I of s as common, this is one algebraic equation. Initially I am taking all the initial conditions 0, everything is 0, but one equation which can perform this, operation is known as Laplace. One tool which can convert this differential equation into algebraic equation is known as Laplace transform. So I will use Laplace transform to approach the transient. For that, some basics Laplace transforms are required. One more thing, we want to analyze the response of the circuit for t greater than 0. Only one-sided Laplace transform is required for that. What is the original formula for the Laplace transform? We represent Laplace transform by f of s, and f of s is given by integration of minus infinite to infinite f of t into e to the power minus st into dt. And this Laplace transform is a two-sided Laplace transform, and for this Laplace transform you must define the ROC. ROC defines the region of convergence. But here we are not interested in two-sided Laplace transform, because we will solve our differential equation which is t greater than or equal to 0. So we can say we are interested in this one-sided Laplace transform. One-sided Laplace transform. And what is one-sided Laplace transform? One-sided Laplace transform is f of s is equivalent to, f of s is what? The variable in S domain. We will not go into the detailed description of Laplace transform. I hope everyone is aware. You have completed in signal and system. 0 to infinite f of t into e to the power minus st into dt. Always remember how you will read it. We can read it, the Laplace transform of ft is f of s. This is how we can read it. So we are interested in only one-sided Laplace transform. And we don't have to define the ROC, because there are a lot of conditions which this ft will satisfy. We will not go into detailed discussion of that. But this is the basic idea. Now let's start with the few basic Laplace transform. The first Laplace transform, some important Laplace transform. We will discuss here some important Laplace transform. Which Laplace transform we are talking about? Some very important Laplace transform. In this series, what is the first Laplace transform? First Laplace transform is Laplace transform of impulse. And Laplace transform of impulse is given by 1. Always remember, all transform of impulse is 1, whether Laplace, Fourier, every transform for impulse is what? 1, due to its property. So when we are having one function as impulse function, what is Laplace transform of impulse function? The Laplace transform of impulse function is 1. Second function is unit step, and for unit step function, Laplace transform is given by 1 by s. These two Laplace transforms are very important. Why these Laplace transforms are very important? These Laplace transforms are very important because they call, whenever they call, find the impulse response. So impulse response means input of the system is impulse. Whenever something is a step response, means input to the system is a step. Step means this is unit step, one step. One function which is having height equal to 1 for t greater than or equal to 0. At t equal to 0, some discontinuity is there. So these are two. Whenever, always remember, when input to the circuit is delta t, the response is called impulse response. This is one of the fundamental characteristics of LTI system. How you describe your LTI system? When input to the system is unit step, it is impulse, it is known as impulse response. In same way, when the input to the system is a step, it is known as a step response. So these two are very important. They will ask this using name. What are the next? Next is, we are interested in the third Laplace transform, that is, we are interested in the third Laplace transform. And what is third Laplace transform? Third Laplace transform we are having is e to the power minus of at for a greater than 0. And what is Laplace transform of this function? 1 divided by s plus a. I am using only those Laplace transforms which we will use in our solution of the circuit, nothing else. Fourth Laplace transform is t into e to the power minus of at for a greater than 0 for same condition. And this Laplace transform is 1 divided by s plus a whole square. Whenever we are solving the transient using Laplace transform, we have to go to the Laplace domain and we have to come back from the Laplace domain to time domain. So one Laplace transform is required and inverse Laplace transform is also required, but for that we use analytical methods, we don't go to the formulas. The fifth is what is Laplace transform of this function? Sine of omega naught t into ut. Always remember the Laplace transform of this function is given by omega naught divided by s square plus omega naught square. Sixth function is what is Laplace transform of cosine omega naught t into ut, and this value is given by s divided by s square plus omega naught square. You can remember that everything I am defining is greater than 0. Means if you talk about e to the power minus at, always remember e to the power minus at, the Laplace transform is u of 1 divided by s plus a only if this exists for t greater than 0. And this is also, the function is defined for t greater than or equal to 0. Either you can write some function is defined at t greater than or equal to 0, or you say I am multiplying that function by ut, both are the same thing. Fine. Next very important property we are interested in is shifting property. Shifting property, we will use these properties. Shifting property of Laplace transform. What shifting property of Laplace transform says? Shifting property of the Laplace transform says that if you are having ft and ft having Laplace transform f of s and f of t plus minus t naught is there, means time domain signal is shifted by t plus minus of t naught, then Laplace transform will be f of s into plus minus of st naught. Very important property. I will use this property. Means what is example of this property? Whenever I say ut having Laplace transform 1 by s, then if ut is shifted by 1, what will be the Laplace transform? Then Laplace transform is 1 by s into e to the power minus of s. Always remember, because sometimes they give input as some pulse as a input, and when you have some pulse as a input, you have to use this shifting property. Very important. What is next? We will use few theorems. We will use first is known as initial value and final value theorem. Here initial and final value theorem. Laplace transform. What is initial and final value theorem of the Laplace transform? Initial and final value theorem of the Laplace transform says that initial and final value theorem of the Laplace transform says that always remember initial and final value theorem is only applicable for non-oscillatory system, means it is only applicable for the one-sided system, and system must be stable. There are a lot of limitations. So what is initial value theorem says? Initial value theorem says that you will learn all this concept in your signal and system course. Here we are having discussion only about what is important for the network analysis. Because we are not describing our system, we are using Laplace transform as a tool to convert differential equation into algebraic equation. That's it. We will not comment on behaviors of that equation. So initial value theorem. What initial value means? What? The initial value means the initial value in the time. What is meaning of this? The meaning of this is very simple. Initial value in time, and this is applicable to one-sided Laplace transform only. What it says, that the value of f of 0 is equivalent to s into f of s for s approaching to infinite. Wait a minute. Hello. Okay. So this is known as the value of time, and this represents s approaching to infinite. This is our initial value theorem, and initial value means initial value in the time. Always remember, not applicable for the two-sided signal, not applicable for the oscillatory or what you call marginal undamped system. The second, what is second? The second part is final value theorem. Final value theorem means what? Final value in the time. Final and what is final value theorem? Final value theorem says that the final value in the time, f of infinity is what? S into f of s for s approaching to 0. Final value theorem means not final value of s. There is nothing like final value of s. Final value theorem means final value in the time domain. So these are important theorems we will use in while approaching the transient analysis. What is next? The next part is how to take Laplace transform of the differential equation. Our main agenda is to take Laplace transform of a differential equation. Laplace transform of derivative or differential equation. How to take Laplace transform of a differential equation? Always remember, when I am having dft divided by dt. Let's say ft can be anything. For in our case, this can be a voltage waveform, a voltage variable or current variable. So what is Laplace transform of this? The Laplace transform of this is given by, provided you know that the Laplace transform of ft is equivalent to fs. If Laplace transform of ft is equivalent to fs, in that case the Laplace transform of d by dt of ft is given by, the Laplace transform of d by dt of ft is given by keep this thing in mind, it is very important. This value is s. Just represent d by dt by s. So s into f of s minus f of 0 minus. This f of 0 minus represents initial condition. This represents what? Initial condition. This represents the initial condition. Always remember that. If you take the derivative of Laplace transform of the second derivative, how this value will looks like? So in normal our RLC circuit, they don't give initial condition, but when we are talking about transient, you will get this initial condition, because we are having all response transient because of initial condition only. So in this case, how I will write? I will write like this. This is second derivative, so I will write s square into f of s minus s into f of 0 minus. So second power to 1, and then you have to come by this d by dt of f0 minus, and this 2 represents initial condition. And this you can expand up to any derivative. We are interested only till second derivative only. So always remember, and if you make initial condition equal to 0, can I say, you can make one note for all initial condition for all initial condition 0, for all initial condition 0, we can replace d by dt by s, and integration we can represent by 1 by s. So these are two important observation. When initial condition is 0, like your other subjects where initial conditions are 0, linear control system, in this or linear control system where the initial linear control system means no initial condition, the system will obey the superposition. For this condition you can replace derivative by s and 1 by s by integral by 1 by s. So these are few important Laplace transform which is needed. Now how this Laplace transform is applicable to our components? What components we are having? Our circuit is forming a differential equation only because of two energy storing element. हमारा जो सर्किट है उसमें डिफरेंशियल इक्वेशन का फॉर्मेशन ही इसीलिए हुआ है कि हमारे पास दो एनर्जी स्टोरिंग एलिमेंट है, और वो दो एनर्जी स्टोरिंग एलिमेंट कौन से हैं? एक है कैपेसिटर और एक है इंडक्टर. सो लेट्स टॉक अबाउट दिस. Laplace transform for components. And what is the first component? First component, let's say we are having, this is very important point, because this will gives you your analysis, this will makes your analysis easier. We will shift from differential equation to algebraic equation. तो पहला जो हमारे पास कंपोनेंट है, that component is capacitor. एक कैपेसिटर है, the voltage across capacitor is VCT and current is ICT, and we are saying that this capacitance is having value C. तो हमारे पास एक कैपेसिटर है, उसके अक्रॉस हमने कुछ वोल्टेज लगाया है, पोटेंशियल डिफरेंस क्रिएट किया है, और उस पोटेंशियल डिफरेंस की वजह से इसमें करंट फ्लो हुआ है ICT. What is relationship between these two variable? The relationship between these two variable is given by ICT is equivalent to C dVCT divided by dt. Now what we can say, we are having two variables and this is also differential equation. So can I say the Laplace transform of IC, the current across capacitor, I am writing this Laplace transform as IC of S, and the Laplace transform of VCT, I am writing it VC of S. We are taking Laplace transform of these two variables. Now what I can say, if I take the Laplace transform of equation 1, let me take this. Laplace transform of equation 1, how equation 1 will looks like? Laplace transform of equation 1, Laplace transform of equation 1, and what it looks like? It looks like this. ICT equal to C dVC by dt. So IC T equal to C dVC T divided by dt, or you can say, if you take Laplace transform, where we will consider the initial condition. So IC of S can be represented as C times of S into VC of S minus VC 0 minus. VC 0 minus is the initial condition. Now how we can represent the capacitor? We can represent the capacitor using two formation. Means if this is the current equation, what will be the voltage equation? So you can say the voltage equation can be written like this. IC of S divided by C equal to what? Equal to S into VC of S minus VC 0 minus. Or I can write this IC of S divided by C plus VC 0 minus divided by S, and this is divided by S. This value is what? VC of S. This is the voltage across. This is the voltage across capacitor. So how I can represent the capacitor? I can write the capacitor like this. If I am representing this as my capacitor and this voltage is what? This voltage is VC of S. Then can I say If this voltage is Vc of S, what is here? Here we are having one capacitor, and capacitor value is 1 by S into C. So whenever you are having capacitor in the circuit with initial condition you can replace it by 1 by SC. And what is current here? The current here is IC of S. IC of S is the current entering into the capacitor. So it is 1 by SC into S, IC of S. Plus we are having one voltage source, and what is the value of voltage source? The value of voltage source is Vc of 0 minus divided by S. This is the representation of capacitor in the Laplace domain. This is representation of the capacitor in the Laplace domain. Representation of the capacitor in the Laplace domain when you are having finite initial condition. Representation of capacitor in Laplace domain with initial conditions. With initial condition, this is representation of a capacitor. This representation of a capacitor in the Laplace with initial condition. Now what I can say that the capacitor can be 99. Okay, the capacitor can be written as the capacitor, if you are having this your capacitor in the time domain C, this is ICT, this potential is VCT, and if you take Laplace transform of this, and this capacitor is, let's say it is having initial condition of Vc 0 minus, then what I am saying, in Laplace domain you can replace this capacitor by what? One divided by S into C Vc 0 minus divided by S, and here across these two terminals you can take the voltage. This is the which equivalent? This equivalent is known as voltage equivalent. You can have the current equivalent also. This is the voltage equivalent in which domain? This is the voltage equivalent in the voltage equivalent circuit. Capacitors voltage equivalent circuit in the transform domain, Laplace domain. One more thing we are very clear from this, and what is that thing? If initial conditions are equivalent to 0, if initial conditions are if initial conditions are 0, if all initial conditions are 0, what we can say, this dependent voltage source will be 0. If dependent voltage source will be 0, can I say for initial condition 0, your circuit will looks like this. This is VCT, this is IC, this is C, and I am saying that all initial conditions are 0. Then what is its Laplace transform? Its Laplace transform is given by 1 divided by S into C this value is Vc of S and this value is I of S. This is the idea. Now this is one of the equivalent which is known as voltage equivalent of, means initial condition is given in terms of voltage. Now you can have the current equivalent also. When you write this, when you write the equation, this is the voltage equivalent form. This is the voltage equivalent form. What next we want to comment? Next we want to comment is this. Whenever we are having zero initial condition, then by the use of KVL we can write Vc of S equal to what? 1 divided by SC into IC of S. 1 divided by SC IC of S. Always remember, Vc of S, voltage in S domain divided by current across capacitor in S domain, represents the resistance in S domain. So this is the resistance of the capacitor dependent on variable S. When you go through the signal and system, you know that what S represents. S represents, so what is S? S is generally J into omega. So this represents J into omega. That's why this is known as frequency dependent resistance. How you can represent it? How you can say this expression represent frequency dependent of the capacitor. So this is one of the representation. This is the one of representation. Let's go for the next representation. What is next representation? We have our standard equation. We have our standard equation like this. IC of S equal to, I can draw the current equivalent in the Laplace transform. IC of S equal to what? IC of S equal to C times of S into V of S minus V0 minus, and this is Vc, this is V0 minus is the initial condition of the capacitor. यहाँ जो V0 minus है वो ये बताता है कि कैपेसिटर का इनिशियल कंडीशन क्या है. Now how we can draw the current equivalent? Can I say okay, if this voltage is Vc of S and this is one capacitor, and capacitor's impedance is 1 by S C into S. So what will be the current in this direction? If I write this current as I1, what is the value of I1? So you can say the value of current I1 is applied potential difference. So what is applied potential difference? Vc of S. Vc of S divided by 1 by Cs. So this is Vc of S divided by 1 divided by Cs, which is equivalent to C into S into Vc of S. So first part of the current is done. The first part of the current is done. What is the second part? Second part, you are having current in the opposite direction. And what is value of that current? And that current is what? C into Vc of 0 minus. And this current is equivalent to what? This current is equivalent to IC of S. So this is the Laplace equivalent of the capacitor when initial conditions are finite. But if you take Vc0 minus as 0, you can say this part will act as an open circuit. If this part will act as an open circuit, you will get the original circuit. So original your expression as previous expression. So can I say this represents this? So you can use when you are solving your circuit from the Laplace domain, you can use any of the circuit. This circuit is also fine and previous circuit is also fine. You can use, you can replace your capacitor by this value. This is the more accurate circuit, or you can use replace your capacitor by this value. This is also fine. So Laplace current equivalent of capacitor. Current equivalent in Laplace for capacitor. I hope this point is clear. Now let's go for the next part, and what next part is saying. Let's go to the next part, and what next part? Next part we are having one more component, that is inductor. Representation of inductor in the Laplace domain. Representation of inductor in Laplace. Representation of the inductor. Representation of the inductor in the Laplace. Representation of the inductor in the Laplace domain. Representation of the inductor in the Laplace domain. So you can say we are having this. We are calling this voltage as VL of t. We are calling this inductor L, and current across inductor I am writing it IL of t. Correct? All are function of time. So what is next? Next we can write the relationship we are having between voltage and current across the inductor is L DIL divided by dt equal to VL of S. But we want to represent this thing in the Laplace domain. So if I talk about the Laplace domain, I can write L into, what is Laplace transform of this? The Laplace transform of this is given by L into S into IL of S minus IL 0 minus into, this is VL of t. You cannot use one variable in the time domain and another variable in the Laplace domain. This is not allowed. And this value is what? VL of S. Either both variable will come from the Laplace or both variable come from the time domain. Correct? This is the voltage representation. So how we can draw it? We can draw this, the voltage equivalent like this. This is L into S into IL of S minus L into IL0 minus. Always remember, IL0 minus is the same initial condition of the differential equation. So you can say here its equivalent will be what? Equivalent will be this. You are having one inductor, and what is inductor's value? If this current represent IL of S, then what is value of this? IL of S multiplied by IS is the first part of our voltage. And what is the second part? This is VL of S. What is second part? Second part is this. And this value is what? L into IL0 minus. And summation of this two voltage means when current will flow through this, what will be the potential drop? The potential drop will be this. L into S this potential drop will be L into S into IL of S, and this value will be what? This value will be VL of S. This is the which equivalent? The voltage equivalent of initial condition is given in form of voltage, and you can have the initial condition in form of current also. This is L into S into IL of S. We can have the initial condition in the form of current also, and what these are in it? We can have the initial condition in form of current also. So if I write this expression in form of current, can I say VL of S, we can say VL of S is represented by what? L Henry times of S into IL of S minus IL0 minus. Always remember, IL0 minus represents the initial condition. Now you can write VL of S divided by L plus IL0 minus, this is equivalent to IL of S, and it is multiplied by S, so I am dividing it by S. So if we are interested in the current equivalent, the current equivalent is given by this. First we are having VL of S. So here I am saying the potential of this point is VL of S. This is VL of S, the potential across inductor, and VL of S divided by LS. So between these 2 points we can have one inductor with the frequency dependent capacitance L of S. Now what is next? Next we are having current source in the same direction. So this current is also you are having in same direction, VL of S divided by L of S. And here we can have one more current source. IL0 minus divided by S. And the sum of two current. What is sum of two current? The sum of two current is represented by IL of S. This is which equivalent? So whenever you are solving your network, you have to represent your energy storing element in form of one of the form. Maybe the current equivalent. This is the idea. Current equivalent in Laplace. तो हमारे पास दो चॉइसेस अवेलेबल हैं, इधर आई विल गो फॉर व्हाट, द करंट इक्विवेलेंट, और आई विल गो फॉर द वोल्टेज इक्विवेलेंट. या तो मैं करंट इक्विवेलेंट के बारे में बात कर लूं, या मैं बात कर लूं किसी वोल्टेज इक्विवेलेंट के बारे में फॉर इंडक्टर एंड कैपेसिटर. अच्छा, दो ही ऐसे कंपोनेंट हैं जिनमें जो एनर्जी स्टोरिंग एलिमेंट्स हैं सर्किट में. रिमेनिंग कंपोनेंट्स आर नॉट एनर्जी स्टोरिंग. इफ वी आर हैविंग वन मोर कंपोनेंट, so one more component is what? Resistor. So you can say if this is my resistor and here this resistor is having value R, then you can say VT by IT or VS by IS. In both the cases, the resistance of this is equivalent to R. There is no need to take the Laplace transform of resistance. Why we are saying this? Because the resistance of the resistance of this, the property resistance is independent to the frequency. At least at our interest, it is independent to the frequency. Where the inductor and capacitor, the behavior of inductor and capacitor is frequency dependent. So, what is Laplace transform of R? The Laplace transform of R is R. No problem with the resistor. So these are the basic concepts which we will use in analysis of what? In analysis of our transient with Laplace transform. So what is the idea? The idea is very simple. The idea is very simple. Approach to solve the circuit. Approach to solve transient using Laplace transform. Using Laplace transform. First, take Laplace transform of the component. Step number 1. Take Laplace transform of the circuit. What is the first step? First step is take Laplace transform of the circuit with initial conditions. You should take all initial condition into the account. What is next step? The next step we are having is this. Step number 2. Step number 2 is what? Step number 2. Apply basic KVL and KCL. Once you convert your whole circuit into the Laplace transform, what you have to apply, you don't deal with the differential equations now. You can solve using KVL and KCL. Apply this. Accordingly, apply KVL and KCL. So, what is the first step? First step is take Laplace transform of the circuit. What is second step? Apply KVL and KCL to find required variable. Maybe your required variable is current or voltage, you can have. What is the third step? Third step is to take inverse Laplace of the same circuit. So step number 3, take inverse Laplace. Take inverse Laplace transform. Using this method, you can solve. Following this three methods, you can solve all your problems which we have discussed in the transient. You can use this method to solve them. This problem again using Laplace transform. So let's go to the circuit and try to solve few problems. So we are taking first few problems from the book, and then we will solve the remaining. Okay, this is one of the problem. What is this problem saying? This problem is saying that a network of the figures which k is moved from position A1 to position 2 at t equal to 0, steady state current having the previously been established in the RL circuit, find the particular solution for IT. Okay. So we are interested in the solution of this equation. Can I say the circuit is given with the switch, and the circuit with the switch can be analyzed in two format. There are two intervals for which we will analyze this circuit. The first one is t equal to minus infinite to t equal to 0 minus. This is the first position of the switch when switch was connected to the position number 1. Position 1, and this point is steady state point of position number 1, and second starts from t 0 plus to t equal to infinite. So always remember, we will take Laplace transform for this condition, and this time interval is what? This is the switching time. Okay, and this is for position number 2. Position 2. We are always interested in any response, means you are interested in the response of current or voltage. We are interested in all the responses for t greater than or equal to 0. So we are interested in this. For position number 1, we have to analyze our circuit for t less than 0. And how this circuit looks like at t less than 0? At t less than 0 is the steady state point, and in steady state condition it is given that this voltage source is connected to the switch number 1 through R1. This value is R1, and here in steady state you can represent it by short circuit. Inductor will be short circuited. So what is IL0 minus? The IL0 minus is given by V divided by R1, and IL0 minus represents the current across इंडक्टर. तो यहाँ आप देख सकते हैं कि IL0 माइनस क्या बताता है? करंट अक्रॉस इंडक्टर, और इंडक्टर के अक्रॉस जो करंट है वो आप कॉपी कर सकते हो जस्ट बिफोर स्विचिंग टू जस्ट आफ्टर स्विचिंग, एंड दिस करंट इज अगेन V divided by R1. Once you know the initial condition, whether it is time domain approach or either it is Laplace domain approach, once you know the initial condition, you don't need to go back to the circuit. We are interested in initial conditions only, and there is no use of this circuit except finding this initial condition. If initial condition is known, your switch has moved to the position number 2. So can I say, when it is connected to the position number 2, means our circuit for t greater than 0 is this. For t greater than 0, how our circuit will looks like? One resistor, second resistor, and one inductor. This resistance is R2. So can I say, here we are having one R2, here we are having one R1, and here we are having one inductor. And what is value of inductor? The value of inductor is not given, the value of inductor is L. But initial condition of the inductor is also given. What is initial condition of the inductor? The initial condition of the inductor is, the initial condition of the inductor is given that IL0 minus is equivalent to V divided by R1. This is given. And they are asking current in which direction? They are asking current in this direction. Now, if the circuit is available at t greater than 0, and what approach we are using? We are using the Laplace transform approach. So just take the Laplace transform of this circuit. If we take Laplace transform of this circuit, if I take the Laplace transform of the circuit, how circuit will looks like? The circuit will looks like this. There is no change in R2. R2 will be as it is. There will be no change in R1. So R1 will be as it is. And what is the story of this inductor? The inductor will be replaced by its Laplace equivalent. So what is its Laplace equivalent? So its Laplace equivalent is given by this. Always remember, L will be replaced by L into S. And when you draw the Laplace equivalent, do you know what is the we are writing which equivalent? I am writing the voltage equivalent, and here we are having negative, positive, L into I0 minus. And what is L? L is given L into I0 minus. What is value of I0 minus? B divided by R1. Correct? This is which equivalent? The voltage equivalent. You can see this. We have derived this in our equation. When you go to the equation, we have talked about this. How you will represent your inductor? You will represent your inductor by this equivalent. Inductor is represented by this. L is replaced by L into S minus plus L into I0 minus. So we did the same. So if we did the same, this is our circuit. This is the circuit in the Laplace transform domain. Now I am interested in, and what is the Laplace transform of this current? The Laplace transform of this current I, the Laplace transform, we are taking the Laplace transform of the whole circuit. So if this current is I, here we are having current I of S. So we did our first step. What is the first step? First step is to apply the KVL. First step is to take Laplace transform of this circuit. So if we have taken Laplace transform of the circuit, now we are now what is the second step? The second step is to apply the basic KVL and KCL. So what is potential drop here? The potential drop here is minus R2 into I of S. If you enter from this direction, this will be plus, this will be minus, and what is potential drop here? I of S into R2. If you are entering from this direction, this is what? Plus minus. This value is I of S into R1. And what is potential of this point? The potential of this point is plus minus. Always remember, across this passive element, current always enters from the positive polarity. And this value is what? This value is given by L into S into I of S. Now we are having four components in the circuit. Across all components, we know what is the potential drop. So minus R2 into IS minus R1 into IS minus L into S into IS plus L into V divided by R1 equal to 0. What we did? So we followed the second step, and what was the second step? The first step is to take Laplace transform of the circuit, and the second step is what? Second step is apply the KVL and find that variable in which you are interested in. So if I solve this is KVL equation, and if I separate this I of S, can I say I of S, I can take common from the circuit. If I take I of S as common, what we are having? R1 plus R2 plus LS. We are having here R1 plus R2 plus LS, and this value is equivalent to what? This value is equivalent to L into V divided by R1, because this all three values are negative, so when it go opposite side it will be plus. So LV into R1, L into V divided by R1. Always remember this V is the initial condition, L into V divided by R1. What next? Next we can say I of S can be written as L into V divided by R1 multiplied by R1, or divided by what? L into S plus R1 plus R2. Correct? Now we know the variable in S domain, but we are not interested in the S domain things. We are interested in the time domain. And what is to get the time domain, you have to take inverse Laplace transform of I of S. The inverse Laplace transform of I of S will be represented by what? I of t. And what is value of I of t? Because we are aware of this inverse Laplace transform. The inverse Laplace transform of 1 divided by S plus A is equivalent to e to the power minus of AT into UT. So we want the coefficient of S equal to 1. So let's take L as common. So from this expression I can take S as common. So L as common. So L and L cancel. This is V divided by R1 divided by S plus R1 plus R2 divided by L. Always remember, whatever appears in addition of S is known as 3 dB frequency, and opposite of 3 dB frequency is time constant. So what is time constant of the circuit? The time constant of the circuit is L divided by R1 plus R2. In Laplace domain also you can calculate this time domain parameters. And what is, if I take inverse Laplace of this, IT is equivalent to what? V by R1 will be as it is. And what is inverse? 1 divided by S, and this is A. So this is e to the power minus of R1 plus R2 divided by L into T into UT. Always remember this responses are valid only for t greater than 0. And what is idea to write something as t greater than 0? If you want to write something as t greater than 0, the two ideas are there. What are these two ideas? Either you can write IT as V divided by R1 e to the power minus of R1 plus R2 divided by L into T for t greater than 0, or you can multiply this, or you can multiply this by UT. So for every question the procedure is same. And what is the procedure? First take the Laplace transform of the circuit, then apply, because once you convert this circuit into the Laplace transform, now this is your basic circuit, but like a DC circuit with one variable S. So you can approach this circuit by your simple KVL and KCL analysis. Once you done with the KVL and KCL analysis, try to get the desired variable. What is variable you are interested in? In this question you are interested in IS. So you have find the value of IS. Now try to get inverse Laplace transform of this. So you can use any of the approach. If you are comfortable in the time domain approach, use that approach. If you are comfortable in the frequency Laplace domain approach, you can use this approach. Let me give you a few more example on this concept. Okay, let's take one previous year problem. What this previous year problem is saying, a combination of 1 microfarad capacitor with initial voltage VC0. It is given that a capacitor with initial condition is given VC0 equal to minus 2 volt in series with 100 ohm resistor connected to the 20 milliampere ideal DC current source. Okay, this is one DC current source By operating both the switches at t equal to 0, in this circuit two switches are given. One switch they are opening at t equal to 0, another switch they are closing at t equal to 0. Shown in the figure. Which of the following graph shown in the options approximate the voltage? Okay, I have not drawn that graphs, but we will try to analyze this and we will try to draw that graph. That in this is one previous year question, and in this previous year question 4 options are given. In those 4 options 4 graphs are given. So once we are able to get that equation, we can draw the graph. That is not difficult job. So what they are saying, for t less than 0, there is no current source and there is this switch is also open. So from our circuit we cannot calculate the initial condition, but they have given the initial condition. And what is the initial condition? The initial condition is VC0 minus equal to minus of 2 volt. This is given. If this is given, we have to analyze the circuit for t greater than 0. Let's analyze the circuit for t greater than 0. Can I say, if I analyze the circuit for t greater than 0, how this circuit will looks like? The circuit for t greater than or equal to 0. What is your circuit at t greater than or equal to 0? At t greater than 0, the switch S, can I say, when t is greater than 0, two things are happening in the circuit. The switch S1, I am calling this switch as S1. I am calling this switch as S1 and I am calling this switch as S2. For t greater than 0, the switch S1 is open and switch S2 is closed. Switch S1 will, if switch S1 is open, this allow this current to flow through the circuit, and if switch S2 is closed means you can have the closed path, otherwise how you will have the current in the circuit. So this is the condition. Now what we are saying, let's draw our circuit. And what is the step number 1? The step number 1 is to draw the circuit in time domain for t greater than 0. So this is our circuit. This is one current source, $20 milliampere current source, correct? And I can call this current as I. Then what we are having for t greater than 0? We are having one capacitor. So one capacitor is given. Also, the polarity of the initial condition is also given. This is plus minus. So let me write plus minus VC. The value of capacitor is also given, but let's write it C. What else is given? The else is 100 ohm resistance is also given. So let me take 100 ohm resistance here. 100 ohm resistance is also given. This is 100 ohm resistance. And let me write it here. We are writing the circuit for t greater than 0. For circuit t greater than or equal to 0. But this circuit is available in the time domain. So let's take Laplace transform of this circuit. If I take the Laplace transform of the circuit, how I can take the Laplace transform of the circuit? Can I say this current source is activated for t greater than or equal to 0. If this is activated for t greater than or equal to 0, what is the Laplace transform of ut? The Laplace transform of ut is 1 by s. So what is Laplace transform of I into ut? Because this current is valid only for t greater than 0. So I can write this as a I by s. So this value is I means 20, or let's write it I by s. I of s divided by s. This is the value of current source in the circuit we are having. What is next? Next we are having the capacitor. What is the equivalent of capacitor? The equivalent of capacitor is, you can replace your capacitor by 1 by Cs, and here you are having a source. Because how we are representing our capacitor, I am drawing the voltage equivalent of that capacitor, that is 1 by Cs, and initial condition is given in form of voltage. That value is Vc0 minus divided by 2. So you can say this value is what? Minus of 2 by S. Because we have calculated this equivalent when we go to okay, so here you can say 1 by S into C into Vc of 0 minus divided by S with the same polarity. The polarity of these two are same. Always remember this. So when I draw this circuit, this is minus 2 by S because initial condition is given with the minus polarity. You can say this value is minus 2 volt. What else they are talking about? 100 ohm resistance. And can I say the 100 ohm resistance will not vary. This value is 100 ohm. This is your circuit. And what they are asking? In this circuit they are asking what is the voltage across current source. What is the voltage across the current source? They are asking this voltage Vs. Means in our circuit they are asking this voltage, and this voltage is, let's say, Vs. They are asking this voltage in the time domain. Voltage across current source they are asking. Okay, if our circuit is available in the Laplace domain, what is the first step? First step is to take Laplace of your circuit. What is the second step? Second step is to calculate the desired variable. So what is our desired variable? V of S is our desired variable. Means this V of S is also available in which domain? S domain. So first we will calculate the V of S, then we will calculate the inverse V of S. This is the exact idea. So let me draw the circuit again for clarity. Here we are having what? I of S divided by S. Then we are having 1 divided by Cs. Then we are having two by S. Then we are having $100. Correct? And we are interested in this potential. We are interested in this potential. Which potential I am interested in? I am interested in this potential. We are interested in this potential. So who will determine this potential? We are having current source, and current source will not take care of any initial voltage or anything. They just current will flow into this. So can I say, if I apply the KVL, what is potential here? Vc of S or Vs of S, the voltage across source, is given by what? This potential is equivalent to summation of this potential. So I can say this value is, or let me write the KVL here. What is second equation? The second step is to apply the KVL or KCL. So you can say this is Vs of S. Vs of S represents the voltage across current source, minus 1 by S into C into I of S divided by S. Correct? Minus 1 by Cs, and this is I of S divided by S. And this value is minus 2 by S. So this is plus 2 by S. Because we are going from plus to minus, so minus of this voltage is what? Plus. And what is this? This is 100 multiplied by, this is the resistance, resistance multiplied by current, which is I of S divided by S. This is our KVL equation, which we can write very easily, and summation of all this voltage is equivalent to 0. 1, 2, 3, 4. 1, 2, 3, 4. 4 components are there, and we have written 4 voltages for this. Now, we know that what is the value of current source? The current source is having value 20 milliampere. So you can say here the value of I of S is 20 milliampere. Okay, what else is given? The value of capacitor, is there any capacitor? Yes, 1 microfarad. So value of capacitor is given as 1 microfarad. Remaining everything is known, only capacitor and this in the current source is not known. So we can write Vs of S, the voltage across current source, is given by what? 1 by SC and I of S by S. So 1 divided by S square, I can write 1 divided by S square, I can write. And what is remaining two values? 1 divided by S square, 1 divided by S square, and what else? I of S divided by C. What is I of S? I of S is 20 milliampere. 20 into 10 raised to the power minus 3. Make the same unit. And divided by C. What is C? C is 1 into 10 raised to the power minus of 6. This is our step number 1. Don't call this 20 milliampere by 20 by S. Don't do that, because we have already converted in. The IT is 20 milliampere and we are writing 20 milliampere by 20 by S. So don't do it again. What is next? Next we are having 2 by S. So this is what? 2 by S, and here we are having negative sign, because this is, we are going plus to minus. So then we are having what? 2 by S. One more variable. What is one more variable? Minus 100 I of S. I of S is what? 20 milliampere. 20 into 10 raised to the power minus of 3. Divided by what? S. Correct? This is the value of V of S. This is what? 2000. 2000 into 10 raised to the power minus 3 is what? You can say this value is 1 by S square into, this value is 2 into 10 raised to the power 4. Minus 6, minus 3 is plus 3. And this value is, so 2 into 10 raised to the power 4. This value is, can I say, we are having 2 into 10 raised to the power 4 divided by S square. This value is 2 by S. And this value is 2000 into 10 raised to the power minus 3 is 2. So minus 2 divided by S. And this value represents Vs of S, the voltage across current source. Plus minus cancel. Do we know what is the inverse Laplace transform of 1 by S square? So always remember 1 by S having inverse Laplace transform ut, and if you multiply it by t, this will be what? 1 by S square. If you multiply it by t square by 2, this will be what? 1 by S cube. Step, ramp and parabola. These are sufficient. So if we are interested in Vs of S, we have to take inverse Laplace transform of this. And what is inverse Laplace of transform of this? 2 into 10 raised to the power 4 into t into ut. This is Vs of t. This is our final answer, but they have represented this option on the graph. So what type of graph this equation is having? This graph is what? I can write this equation like this. Vs of t can be written as for t greater than 0, you can write this as a m into t. For t greater than 0, greater than or equal to 0. And what is m? M is slope, and slope is given as 2 into 10 raised to the power 4. So you can say this is nothing but a straight line with the slope 2 into 10 raised to the power 4. This represents Vs of t and this represents t. So this is in the final answer, this represents one straight line, and a straight line with these values. 2 into 10 raised to the power 4 is the value of that straight line. I hope this analysis is clear. This is one previous year question. Let's go to the next. What is next? Okay, let's take one more question. This question. Okay. In the circuit, figure has initial current IL0 minus is given as 1 ampere through the inductor, and the initial voltage is also given as minus 1 volt across the capacitor. For Vt equal to ut, the Laplace transform of the current It. In this circuit, they are directly asking about the current I of Laplace transform of current It. So we know that the Laplace transform of current It is given by what? They are asking about the Laplace transform of current It. So Laplace transform of current It is given by I of s. The Laplace transform of current It is given by what? This is given by I of s. Fine. So let's draw. What is our idea? Our idea is to take Laplace transform of the circuit and then apply the basic KVL, KCL and get the variable. So can I say we are having this circuit. This is your time domain circuit. This value is 1. This value is 1 inductor. And what is initial condition? IL0 minus is 1 ampere. Then we are having 1 capacitor. And this value is IT. This value is L and this is C. Correct? This is our circuit as it is mentioned in the question. And what they are saying, Vc0 minus equal to V of t is equivalent to ut. So they are they can ask the question. They can ask the question, either they can ask that what is the step response of the circuit, or they can ask Vt equal to ut. And one more thing, what is given? The current across inductor IL0 minus is given by what? IL0 minus equal to 1 ampere. And what is direction of current? So they have mentioned only this direction. So we are taking current in this direction. Vc0 minus is minus 1 volt. Vc0 minus equal to minus 1 volt. Now let's take the Laplace transform of this circuit. This is the main step, because we are using Laplace transform as a tool to solve this differential equations. How we can analyze it? So we can say first we are having Vt. So what is the Laplace transform of ut? The Laplace transform of ut is 1 by s. This value is what? This value is 1 by s, because Vt is given as ut, step function, and what is Laplace transform of step function? 1 by s. Then next component is what? Next component is our resistor. So I will draw this resistor as it is. This is 1. What is next component? Next component we are having inductor. So I will draw the inductor. L into S. Always remember, with inductor we will go from minus to plus. L into S multiplied by L into I0. So L into I0 is what? L. And what is value of L? 1. So this value is 1. Then we are having one capacitor. So what is capacitor? Capacitor is having value C. So I will write it 1 by S, because it is 1 by CS and C equal to 1, I think. Everything is 1 farad, so I can write 1 by CS. And here we are writing the initial condition. Always remember this two things. This comes with minus plus, and this with capacitors comes with plus minus. And this value is minus 1 divided by S. This is your whole circuit. So first step is to take Laplace transform of the circuit. And what is second step? The second step is to calculate the desired variable. Now in time domain we are having variable it. So in Laplace domain this variable is what? I of s. Now apply a KVL. So if you apply the KVL, this value is 1 divided by s. This value is what? Minus I of s. This variable is what? Minus s into I of s. Potential across this plus 1. This value is minus 1 by s into I of s plus 1 by s. This is our whole equation. We have written the potential across every component. So can I say, if current will enter from this terminal, this will be what? Plus minus I into 1. This potential will be what? I into S. This value is L into I0 minus. So L into I0 minus, both are 1. So this I am taking 1. What is potential here? Plus minus I divided by S. And this value is minus 1 divided by S. So you are going negative to positive. It is 1 by S. Positive to negative, minus of IS. Positive to negative, minus of this value. Negative to positive, this is plus. Positive to negative, this is minus I of S. And positive to negative is negative, but negative of this number is 1 by S. This is our KVL equation. Now let's solve the KVL equation and find the value of IS. This is the only question they are asking. So can I say the value of IS will be, IS I can take common from here, here and here. So let me take IS as common. Let's go to the another side. If I take IS as common from the circuit, how our circuit will looks like? From here I can write 1, from here I can write S, and from here I can write 1 by S. So this value will be 1 plus S plus 1 by S. 1 plus S plus 1 by S. And what is this side? 1 by S plus 1 by S, 2 by S, 2 by S plus 1. This value is equivalent to 1 by S plus 1 by S, 2 by S, 1 plus 2 by S. One plus 2 divided by S. And when I solve this, this value will be what? S plus 2 divided by S. This is, we are having numerator, and what is denominator? Denominator is S square. If I take LCM, S square plus S plus 1 divided by S. S and S cancel. What is answer? S plus 2 divided by S square plus S plus 1. So which option is correct here? In this question, s plus 2 divided by s square into s plus 1. So you can take direct Laplace transform of the circuit, and procedure for every circuit is same. What is the first step? First step is to take Laplace transform of the circuit. Second step, apply KVL and KCL and find desired variable. What is third step? Third step is to calculate the inverse Laplace transform. There is no need to apply the initial condition and calculate everything. In answer is included. Why it is included? Because you have included everything. You have included everything in your KVL approach. So you don't have to recalculate it. You don't have to calculate the constant. When we were solving same circuit using differential equation, we need to calculate the constant of the differential equation that is equivalent to the order of differential equation. But here we don't need to calculate because we are including it in our analysis. तो यहाँ हमने जितने भी इनिशियल कंडीशंस हैं वो सारे इनिशियल कंडीशन को एनालिसिस में ही इंक्लूड कर लिया है. अगर एनालिसिस में ही इंक्लूड कर लिया है तो मुझे फिर से इसके सारे कांस्टेंट को कैलकुलेट करने की रिक्वायरमेंट नहीं है. आई होप यू हैव अंडरस्टूड इट. लेट्स गो टू the next question. Okay, what this next question is saying, one LC circuit. Now we are having order 2 circuit, and this question I will explain with both the methods, because in time domain we have solved only RL circuit and RL circuit and RC circuit. तो मैं यहाँ आपको बताऊंगा कि अगर इसको टाइम डोमेन से करते हैं तो आपको डिफरेंशियल इक्वेशन के कुछ बेसिक रूल्स हैं CFPI कैलकुलेशन के, वो याद रखना पड़ेंगे. लेकिन अगर आप इसको लाप्लास से अप्रोच करते हैं तो यू कैन डू इट डायरेक्टली, बट यू कैन अप्रोच इट बाय बोथ द मेथड्स, वेदर इट इज टाइम डोमेन डिफरेंशियल इक्वेशन मेथड और यू कैन अप्लाई द लाप्लास ट्रांसफॉर्म. दिमाग में एक बात बिल्कुल क्लियर कर लें कि लाप्लास ट्रांसफॉर्म इज जस्ट अ टूल विच कैन कन्वर्ट योर डिफरेंशियल इक्वेशन इनटू दैट algebraic equation. Okay, LC circuit is shown in the figure, has inductance equal to 1 millihenry. Okay, inductance is given as 1 millihenry and capacitance equal to 10 microfarad. 10 microfarad. The initial current through the inductor is 0. So inductor की जो initial condition है वो कितनी दी हुई है आपको? 0 एम्पियर दी हुई है. You should be clear of one point. You should be clear of one point that if switch is open and no source is connected here, so the response of this circuit is only complementary function. The response of the circuit or response of the circuit is only because of initial stored energy. Okay. So IL0 minus is what? 0 ampere. It is given. What else is given? While the capacitor voltage is 100 volt, so it is given that VC0 minus equal to how much? This value is 100 volt. This is also given. VC0 minus means initial stored voltage in the capacitor is 100 volt. The switch is closed at t equal to 0, the current through. Okay. So we are having L and C, no power dissipation. So what kind of response you can expect from this circuit? The oscillatory response, because there is no this is the one ideal tank circuit, so there is no energy loss in the circuit. If there is no energy loss in the circuit, it will go forth and back and forth. So this will be oscillatory response. Okay, let's calculate it. But our agenda is very clear. What is our agenda? Our agenda is to take Laplace transform of the circuit, calculate the desired variable. In our case, what is desired variable? The current is desired variable, and then bring back it into the time domain. So let's calculate it. Can I say what is our circuit at t equal to 0? The circuit at t equal to 0, t greater than or equal to 0. How we can draw the circuit at t greater than or equal to 0? The switch is closed. If switch is closed, then we are having one inductor. Inductor is represented by what? L into S. Why L into S? Because initial condition of the inductor is given as 0 ampere. If initial condition is given as 0 ampere, if you are taking the voltage equivalent, you can replace it by short circuit, and if you are taking current equivalent, you can replace it by open circuit. So initial current is what? The initial condition, initial current is given as 0. If initial condition is given as 0, we can directly write replace L by L into S. What is next? Next we are having one capacitor. And what is capacitor? The capacitor equivalent is this. This is one capacitor. So capacitor I can replace by C into S, and the polarity of initial condition is given -100. So you can write again and again. I am drawing my standard our standard equivalent, so that don't be confused with negative and positive. And what this value? This value is given as -100 divided by S. This is the equivalent of the capacitor with initial condition. If initial condition is 0 here, you can also tell that this voltage source is 0. You can replace it by short circuit. And what is the current? Current we are having I. So you can say this current is I of S. We are interested in the value of current I of S. Let's apply the KVL in the circuit. So what is first step? First step is to take Laplace transform of the circuit. What is first step? First step is to take Laplace transform of the circuit. And what is second step? Second step is to calculate the variable I of S. And what is third step? To take inverse Laplace of the circuit. So what is the potential drop here? Let me write the potential drop across every component. So I am writing it here, t greater than or equal to 0. What is current here? Current here is I of S multiplied by L of S. So this potential drop is L into S into I. I am writing I of S, I am replacing it by I. And here what is potential drop? It is I of I we can say this value is I of S divided by C of S. Current multiplied by resistance is the potential. Let me write it clearly. Current always enters from the positive polarity. And what is this? This is -100, it is given. So let's write the KVL. What KVL says? The KVL says that sum of voltages inside closed loop equal to 0. So you are going positive to negative. This is minus L into S into I of S. What is next? Minus of I of S divided by S into C. And what is? You are going positive to negative. So this value will be negative of 100 by S means once you know the equation, which variable you are interested in? You are interested in the I of S, the current across inductor. So can I say the current across inductor is given by, I can take current one side and voltage one side. So current across inductor is given by 100 divided by S divided by LC plus 1 divided by S into C. Or you can write the value of current is given by if I take the LCM, S and S cancel, this will 100 C divided by, if I take LCM, so if I take LCM, LC into S into C, this is LC into S square plus this value is what? 1. Correct? I of S can be written as, if I take L into C common here, because we know the inverse Laplace transform of this variable, A divided by S square plus A square. And what is inverse Laplace transform of this? This is sine of AT into u of t. So what is coefficient of s square? The coefficient of s square is 1. So I am taking LCS common. So this will be what? 100 divided by L s square plus 1 divided by under root of LC. Now, if I multiply the same thing by 1 divided by under root of LC, and if I multiply this by under root of LC, then I can say from this equation what I can write? From this equation I can write this value is, this is 1 divided by under root of LC whole square. So I can write a divided by s square plus a square. And what this represents? This represents sine of what? AT. So a is under root of LC. So under root of LC into t. This is our expression. And can I say under root L and under root of L cancel? So this is what? 100 times of under root of C by L into sine of 1 by under root of LC. Now we can find the value. What is value? You can say the value of IT is 100 times of under root of C. What is the value of under root C? The value of C in this question is 10 microfarad. So 10 into 10 raised to the power minus of 6. What is the value of L? The value of L is given as 1 millihenry. So you can say this value is 1 into 10 raised to the power minus of 3. Fine. What else we are having? We are having, okay, sine of 1 divided by under root of LC. So 10 raised to the power 10 into 10 raised to the power minus of 6, which is value of C, and 10 raised to the power minus 3. 1 divided by this value into t is our answer. And of course this exists for t greater than 0. So this value is what? 100. This value is 10 raised to the power minus 5 plus 3 minus 5 plus 3. Minus 5 plus 3 is minus 2. So when it comes out, this value is 10 raised to the power minus 1. And sine of 10 raised to the power minus of 9. Minus 9 plus 1 is minus 8. When it go, it will be 10 raised to the power 4 into t. So this, what is the final value? The steady state value is 10 sine of 10 raised to the power 4 into t will be the final answer. This is the final answer. This is one of the way you can, one of the method you can calculate. This is one of the method by which you can calculate the value of current in the circuit. What is the second method? The second method is just to form a differential equation. And what is differential equation? If you form a differential equation of this circuit, what is differential equation? What is potential across this? L di by dt. Or let me clear it and let me write it here. L di by dt. And what is current across this? 1 by C integration of I dt. And summation of this voltage is equivalent to what? 0. So we are having integration sign in our differential equation. So let's differentiate it again. So this is L d2it divided by dt2 plus 1 by C into I of t equal to 0. Or you can say the d2it divided by dt2 plus 1 divided by LC into IT equal to 0. Correct? This is one of the way. If you want to, suppose you don't want to use your Laplace domain. Now what is the solution of this d by dt? You can replace d by dt by operator d. we are only calculating the CF solution. The equivalent value is 0. So you can say this is d square plus 1 by LC into IT equal to 0. One of the variable can be 0. So this cannot be 0. So d square divided by 1 plus LC equal to 0. So what are two values are of d? Two values of d are plus minus of iota times of 1 divided by LC. And these are two values. When you are having complex conjugate root, what are the answer? The answer is given by, the answer of given by IT equal to what? IT equal to C1 into cosine 1 divided by under root of LC into T plus C2 into sine 1 divided by under root of LC into T. Always remember this. Now we can find what is the value of I0 plus. Now we have to apply two initial condition. So from this you can calculate the value. So time domain method is also fine. The Laplace domain method is also fine, but keep one thing in mind. Here you have to remember this. So when you go through the mathematics, this is also not a tough task. Very simple solution when you are having complex conjugate roots, imaginary roots. When you are having imaginary roots, what is the solution? C1 into e to cos and C2 into sine. If you are having complex conjugate roots, then you can say e to the power minus of alpha t. So very common format of the solution of differential equation. So that based on that skill, it is very simple. And which one is correct option here? The D option is correct. So this is the approach. This is the idea to solve the transient equation, transient analysis, transient at DC with the help of Laplace transform. So I hope this is clear. In next session we will talk a little bit more about this, and then we will go for general practice session for transient, and after completing the transient we will go to the two-port networks. Thank you very much.